Hello, my name is Anusha Jasti. My class name is 10. This is this is module 2 ICP7 or Spark module. Now here our ICP is about the performing of regression or different performing fitting of different models onto a data set and finding the accuracy, where we use clustering, classification, regression, and which is the best one. Here we have three different data sets. One is the adult data set on which we perform the classification algorithms such as naive Bayes, decision tree, and the random forest. And in the second one, our second data set is a diabetes data set where we perform clustering algorithms, which is our k-means. And in the last data set, which is our cars data set, automobile data set, which is the car data set, where we perform linear regression and the logistic regression, which are the regression models. Coming to the code, we can see that. Now let me explain you the first of the logistic regression, which are the regression models. Here we can see that we are using car data set. Considering only a few the first initially loading, creating a Spark session, and then loading of data, and then creating of data. We are loading the data into a car CSV format and then storing it in a data variable, and then we are naming the columns as label, length, width, and height, which is also car data set. And then we are creating a vector assembly in order to feature these columns, and then we are applying the logistic regression for these models. Logistic regression is nothing but how a frequent of yes or no, whether it's perfect or not. And then we're fitting the logistic regression onto this data set, which we have read using the CSV format. And then we're printing the coefficient, intercept, and the multinomial coefficients. This is the output here. We can see that the multinomial coefficient in matrix and the multinomial intercepts, which is being printed using after fitting the model. We are saving it to a different. We are saving it into a model variable, and then using the dot coefficient matrix gives us the multinomial coefficients, and dot intercept vector gives us the multinomial intercept vectors. That is a logistic regression. And coming the linear regression, it's same about we are using the same data set, the car data set. Here we can see that the main difference between logistic and the linear is that a logistic tells us whether an event is going to happen or an event does not happen, and the linear regression is just a relationship between the dependent variables and the independent variables in our data depending upon our data. Here we are fitting the linear regression model. In the same way, we are reading the data and storing it into variable, and then we are sending the vectors, and then for these vectors we are creating a linear regression model, and then later we fit the model. After fitting up the model, we can see we are performing we are printing out the output like coefficients, intercepts, and the objectives, objective history. We are after fitting the model, we are saving it in the model variable, and then using that we are dot coefficient gives us the coefficient and dot intercept gives us the intercepts, and then we are summarizing the model over this. We are fitting a model over the training data, and then we're printing out a few values, which is the num iterations, objective history. Here we can see that the root mean square error and the error is being displayed here. The root mean square error is 2.5, and this is the objective history, and the number of iterations and everything is being displayed. And now coming to the adults data set. Here we are performing the classification functions on the adults data set. On the adults, we are performing functions, the classification functions we perform on the random forest, naive Bayes, and the decision tree. Now let us take a look at the random forest while the process gets executed. Here we can see that we are loading up the data into a data format, and then we are indexing the data format we are converting the whole data into data frames in order to find the accuracy of the random, in order to fit the model and find the accuracy of the model. And later we are splitting up the data into training data and the test data, and then we are fitting the model using the training data and testing the model using testing our model how perfectly it is being fit on the test data. Now we are creating a random forest classifier and then fitting the model over the training data. We are making the predictions using the test data as seen here, and then we are evaluating our model see. We can just stop by here. We can just give a few analysis of our data. Here we can see that we are given a confusion matrix. Confusion matrix is a true false or a true positive. In the same way, these are the other predictions. Here in the test data and the training data, I given the test to be 40% and the training to be 60%, so that it gets accurate. In order to be more accurate, you can give the training data as 75% and the rest as 25%. This is the respective order. This is the confusion matrix and the precision in there. Here I've got an accuracy of 0.04. At times, this varies upon each and every execution, because the way the training and the test is being split is not permanent. It varies. It is being split randomly, so the accuracy also varies from time to time. And now this model is a naive-based classifier. In the naive-based classifier, here we are splitting up the data into training and testing, and then we are performing our fitting our model onto the training data and testing it on our test data. Predictions are made on the test data, and model is being fit on it. We are using a simple naive-based classifier here. In the starting, we use the read format and store it in the data, and then we are indexing it, and then we are creating data frames from the data, and then performing operation, transforming the data frames into training and testing, and then splitting up. And we are performing different functions. Here also I use 60% and 40% for the training and the test. Here you can see that my accuracy is 0.007. Sometimes it's up to 0.7 depending upon how the data is being split. And the next classifier is the decision tree classifier. Here we can see that in the decision tree, this is also, everything is the same code. Just the part which differs is the part where we apply the classification method. Here we use the decision tree classifier, and then we are fitting the model as it is on the training data, and the predictions are made on the test data, and the accuracy is being print. Depending upon the accuracy is being dependent as usual on the training and the split data. Here also split the data in the 60% and the 40%, and then the accuracy is built. While it is here, I'll just show you the output which is being stored already. For the decision tree, here we can see that I got an accuracy. Okay, it's being still on the process. Previously I got an accuracy of 0.028, and it varies from time to time as being said. And coming to the clustering algorithm, now I got an accuracy of 0.035, which varies. And now coming to the clustering algorithm, we use a k-means clustering. K-means clustering is where k is defined by the user. We can give as much as value for the k, and then depending upon the number of k, the whole data is being divided into those many clusters, and each cluster has a center. And in this one, I'm displaying the center for each cluster, and I've given the number of clusters as 3. And if we give us 4, the whole data is being divided into 4 different clusters, and the centers are being displayed accordingly. And here we are loading up the data set, and we are selecting a few columns from the data set which causes main impact on training, which causes main impact on the classification, and given the input data as columns and output data as all the features rest on that. And here I've said that we need to manually set the columns key value here, and then we're fitting the data over the whole data and making the predictions over the same data, and then we are dividing it into clusters and finding the centers. Here we can see that model.cluster centers gives us all the centers of the 3 clusters formed here, and for every center we are printing each centers. So this is the 3 clusters and the centers for that one. Thank you.